colleges in India, right? How many are from colleges in Bangalore? Anybody? Okay, quite a few. Good. And IITs? Okay. Good. And NITs? No? Okay. All right. Doesn't matter. It's just so. Okay, let's start with this. How many of you are familiar with machine learning? Okay. And how about deep learning? Same set of people, is it? All right. Who can tell me what is machine learning? Yeah, go ahead. Okay. Good. Anybody else? Machine learning? What is the simplest definition of? I mean, I think what you said has all the elements that you have to learn to make machine learning work. But fundamentally, what is machine learning? Okay. Make decisions. Okay. Getting warmer. What else? Somebody said some training data. What did you say? Okay. Imitate a human. Well, that's sort of maybe the end goal. We're not there yet. Imitate a human being. That would be like, I think we are some ways off there. So let me ask you this way: how did computers work before machine learning? Not necessarily always brute force. We built pretty optimized algorithms. Okay. Okay. So let me say it this way, right? No, not necessarily. So we used to build lots of optimized large-scale systems. It's not like we didn't, right? So the big thing that machine learning really brought about is the concept that the machine can learn something new, right? Which the programmer did not necessarily put it in the program explicitly. That's the simplest definition of machine learning, right? Can the machine do something that the programmer did not necessarily teach it to do, right? That's what machine learning is. Like, take a child, right? You how do you teach a child? You show them pictures of animals. You show them, like, this is a cat, this is a dog, and all those things. So that's, you're training the child. That's what you do with a machine learning model. You train it. But then, can the system or the child do something beyond what you trained it to do, right? So if you showed the child a picture of a cat, can it then you showed a picture of a tiger? You never said it's a tiger, but the child can say that's a big cat, right? It can see that there is a similarity. So it can sort of learn new patterns emerge that you don't necessarily teach the child explicitly. So machine learning is basically, a machine can do more things. It can learn. The learning aspect is the key here, right? Yes, it can do analysis, all the things you folks talked about. Yes, it can do all of those things, but fundamentally, all of those things can also be done by the traditional thing, like analysis. It's not like we can't do analysis. Statistics, yes, we can do those statistics, but can it learn new patterns? That's what machine learning or artificial intelligence, broadly speaking, is. Where can it do more things than what you can? I mean, you teach the computer certain things, can it use that to do more things and learn new things? That's what machine learning is. And deep learning is going beyond that to sort of learn deeper patterns and doing more advanced things. Okay, so then today's talk, I'm not going to be covering the basics of machine learning or deep learning necessarily. This is going to be more about how we in Microsoft are using deep learning for ads. So my name is Vishwa Kambalimat. I'm a director of engineering and product management in the AI plus R division in Bangalore. And So these are the three topics I'm going to be talking about today. I'll give you a brief overview of what is Microsoft doing in the field of artificial intelligence, right? Then a brief introduction to ads, right? And then most of the time I'll be spending on talking about deep learning, how we are using deep learning in ads. Okay. So feel free to stop me at any point to if you have any questions. Okay. Uh, I have some chocolates here for people who ask questions, good questions. Okay. All right. All right. So let's start with sort of like the graphs that we have, right? So, we have what we call the work knowledge. These are the knowledge graph from the enterprises. Then you have the user knowledge. This is the knowledge graph about the users themselves, their preferences. It could be brand preferences, product preferences, various other things. And then you have the world knowledge about various things around the entities that exist in the world out there, right? So these are sort of what we call the knowledge graphs that we have, right? And so one of the things that we do at Microsoft is build these graphs so that we can understand the world better. What are the relationships between the various entities, right? Between users and the products and the work they do and the world entities, right? So all of those things, there are interesting connections that we can draw, and using that we can do some interesting inferences which allows us to sort of give a better experience to the users. So one simple example is on the user knowledge. If we build a user graph, then for example we can learn over a period of time what is the brand preferences the user might have, right? So let's say the user prefers Nike as a brand, and that's something we can infer over a period of time based on their activities that they do, whether the things they search for or the websites they go to and things like that. So we have, let's say, inferred that a user prefers Nike brand, and when they do a search to say running shoes, then we know, even though they didn't tell us explicitly, we know that this user prefers Nike brand, so we can show a Nike running shoe. So that's a simple example of how having a rich knowledge graph about the user and their preferences allows us to provide a personalized user experience. Because at the end of the day, it's all about personalization, right? What is all this AI and deep learning and machine learning is all coming down to, can we provide a highly personalized experience, right? Because every user is different in some ways, right? Your needs and your preferences are different. What you're looking for, somebody might be looking for a brand, somebody might be looking for something economical or less expensive or more features or what have you, right? There are different, and this is not like one dimensional, it's multidimensional. So now how can we provide a rich personalized experience? That's what we are trying to solve here, right, at a large scale. Because in the old world, we would show the same ad to millions of people on TV. When you're watching TV, everybody gets to see the same ad. I mean, it's still largely the same. But now when you watch something on the net, then it's very personalized, right? For example, if you went to Amazon and search for a product, and then later on you go and you're on a different site, you might see an ad for that product, because we know that you're trying to buy a camera or something, and so we might show you an ad for that, right? So that's a personalized experience, right? So that's the world we are in. So the three things that's really fueling a lot of innovation is, I mean, AI has been there, right? AI has been there from 1960s onwards. It's not like something very new. But what is the fuel that is really making AI sort of now really take off exponentially is these three elements, right? Now we have large scale data available because we have the cloud, right? You can bring all your data to the cloud, and then you layer AI on top of it. Now you can do a lot of interesting things, right? So that's basically the three things, that confluence of data, cloud, and AI is really bringing about some very rich experiences that previously we could not do, right? So that's the time has really arrived for AI to come and thrive. So if you see the three areas that that sort of enables sort of AI, right? So one is sort of you really need a large-scale data platform, right? How can you handle petabytes of data, right? So in Microsoft, we handle large amounts of data because, as you can imagine, we get millions and millions of queries every day, and millions of products that we have to go handle, and so that's large amounts of data that we are handling every day. So we need a data platform that can scale and allows us to do all these things, right? And so these are some of the platforms that we have that can sort of, for example, Azure Data Lake is a large scale data platform that you can bring, petabytes of data and slice and dice it in interesting ways, do statistical analysis and various things. And on top of that, you want to layer the learning functions, analytics and AI tools, right? And then you have the cloud compute itself, which is the compute and networking infrastructure that allows you to bring the AI and sort of the data together and do sort of computations on top of it, right? And then we have something called cognitive services, right? So as human beings, we have all these cognitive functions, right? We have vision, we have language, speech, knowledge, all of these things, right? How can we bring those elements to the services that we provide, right? For example, on the vision piece, can we do computer vision, facial recognition, image recognition, all of those things at scale, right? And I'll give a few examples in my talk today where given an image, can we detect what kind of image is it? What's the, what type of product is it? What's the brand? What's the color? All of those elements can we extract using deep learning. So there are a lot of interesting things we can do because given an image, can I extract enough attributes so that you can search for it, right? That's one sort of application of it. And on the language piece, a lot of interesting things around spell check or translation, machine translation, right? Linguistic analysis and so on. And speech recognition. Nowadays, I think speech is becoming so mainstream. It's amazing, right? With mobile phone as well as all these smart speaker, Alexa, Cortana, Siri, right? So speech is becoming, again, speech was always there, but with the large scale data that we have, it used to be like we used to have speech recognition, but you need to first, maybe it was before your time, but we used to have the speech recognition systems where you would first need to train that because, it cannot understand you from day one. It needs to understand your accents and the way you speak. So it'll take for a week for you to train that program and then it's ready for your use. Nowadays, you just out of the box, right? You buy an Amazon Echo device, it just works out of the box. Or even your mobile phone, on my phone, Siri, it just works out of the box. How does it do it? Anybody? No training required. Yeah, so basically, you have again large amounts of data available on the cloud that you can use now to train that model so that it can work for different millions. So if you have data for millions of users, right, speech data, now I can train my model. And so now you can make sure that it's working for different people from different nationalities, different backgrounds, different education, all kinds of demographics, and make sure it works well, right? So that's basically why you don't need every user to train that device anymore. Okay, so switching gears. So how many people are familiar with the marketplace? Can you give me an example of a marketplace that you use every day? Digital marketplace. I know you can go to a vegetable market, but what about a digital marketplace that you use every day? A lot of, no, sorry, speak up. Facebook is a marketplace. Sorry? They do. Okay. Anybody else? Amazon. Amazon is a marketplace, right? YouTube, no. Sorry? Unreal? Oh, it's a gaming thing. Okay. That's unreal. Anybody? What about Uber, Ola? Is that a marketplace? What is the, every marketplace has what? Supply and demand, right? So anybody can explain to me what is in, if you're using Uber, what is the supply and what is the demand? No, no, what is supply and demand? That's exactly right. Very good. Okay, here's the chocolate. I'll throw it. Let's see if I can throw it to you. All right. Okay, so every marketplace, a marketplace is where you're efficiently matching supply and demand, right? And it's very fascinating because a marketplace can unlock a lot of value, right? It's not like you could not get cabs before. You can, right? But it was very inefficient, right? How did you get cabs? You have to go stand on the street and hopefully you'll find an empty cab and you hail that cab and hopefully that person will stop and will also accept that you know that, like autos, right? They don't want to go where you want to go, right? So you have to go where they're going. That's not an efficient marketplace, right? So what did Uber do? Uber solved this, created a marketplace where they said, I'm going to efficiently manage supply and demand, right, at scale, right? So now anybody who wants to go from IISc to MG Road, they don't have to figure out, hey, where can I find a cab driver who's willing to take me at a reasonable price to MG Road? I'll sort of do that efficiently. I just open an app and say, here's my destination. And then Uber will figure out, based on all the people who are available, who's willing to take that particular you to that destination for a certain cost, right? So that's efficiency, right? Now the driver is not like looking around to figure out, hey, where can I find somebody who needs a cab? They just sit wherever they're sitting and they wait for Uber to get them a passenger. So that's the problem that Uber solved at scale, is creating this huge marketplace for people who are wanting to take a ride and people are willing to give a ride. And that's what a marketplace can do. And for Bing Ads, we are running an ads marketplace. So in this marketplace, you have supply, which is basically all the users looking for something. They're searching for something, right? That's the supply. They're coming through various platforms like Bing or Yahoo. It could be Google, right? Google is also running an ads marketplace. Microsoft, we are running a marketplace. So these are the two big ads marketplaces, if you will. Facebook also is running an ads marketplace. But they did, obviously they started as a social network, but now obviously they need to monetize. But that's basically the supply, right? And on the demand side, you have people who are looking to sell something, right? So this could be, any company that's looking to sell products, right? So that's the demand platform. So, and the marketplace sits in the middle and trying to efficiently match the supply and demand, right? That's what we are trying to do. Yeah. LinkedIn is so the question is, could LinkedIn be a marketplace? Why don't I open up to the audience? What do you think? Is LinkedIn a marketplace? Yes. Why is it a marketplace? Selling people? We don't sell people on LinkedIn, not yet. What do we do on LinkedIn? Why is it a marketplace? One person, please. Selling skills. Sorry? Yeah. So basically, you have, again, it's a marketplace. It's a marketplace where the supply is the people who are looking for a job or an opportunity, and demand is all these people who are companies who are like looking to fill those positions, right? And LinkedIn is enabling an efficient matching of the job openings to the job seekers. That's basically Of course, the professional network is a big part of it, but efficiently matching supply and demand again. Okay. So in advertising, of course, you guys are all familiar, I'm sure, but just to give the basics, when you search for something, again, running shoes. I like running shoes. So if you search for soft running shoes, you might see some results on top, which are the ads, right? So in this case, Ultra Zero Drop footwear, and soft walk shoes from Amazon, all these are ads. And how do you know it's an ad? We actually tell you, right? We want to be open about it. So we truth in advertising. So we say it's an ad. And then of course you have the what we call organic search results. So these are what we call text ads. And then we have something called product ads. Product ads is where you have an image and you have a description and you also have a price, right? So you can actually go price a product. So that's the difference between a text ad and a product ad. So this is the ads marketplace is basically figuring out what ads to show when you do a query, right? And from the millions of ads that we have in our inventory, which is the right ones to show for this user, for this query, based on their preference, all of those things is going on in the background when you do that query. And within the few milliseconds that we take to figure out what to show, all that is happening behind the screen. And here are the sort of things we do, right, to make that work. So starting from ad selection, right? So we need to understand what is the query, what is the user intent, right? And we need to retrieve ads for that query. And we might retrieve like thousands of ads for a given query. Now, how do I whittle it down to these 4 ads or these product ads, right? So then the rest of the stack, the relevance stack comes into play where we figure out the relevance of the ad to that query. And then we rank those ads, right? Then we also have to predict a response, meaning we have to predict, even though it's a relevant ad, we have to predict if the user is going to click on the ad. You know why? Improve the system, that's one, but more importantly, correct. We don't make money if you don't click. If you just show an ad and you don't click it, we don't make any money. So response prediction is an important part of what we do, because there are some users who may never click on ads for whatever reasons, right? Or some users click a lot of ads. So there's the user dimension is also very important. And then the quality of ads is important, because if I show you an ad from some unknown advertiser, you may not want to prefer to buy from them, right? So, and then we also run an auction actually. So we run a generalized second price auction to figure out what are the ranking of ads, how should we price them, all of those things. Okay, so here are the AI problems. And so ads is a very fertile sort of area for AI and machine learning, because the kind of problems I just talked about in terms of understanding the query, because there's NLP there, right? Because the user can type the query in different languages and different ways of telling the same thing, right? And how can we understand intent, right? That's where NLP come in, so that we can understand how do we categorize those queries, and then how can we rewrite it and expand it so that we can match it to more ads, right? All of those things. And I'll give us some examples later down in the slide deck. And then there's also computer vision, because there are images that we have that we need to match to the queries. And then on ML, we have information retrieval, right? Prediction models, all of those things. And then we also have optimization, things like running an auction or counterfactuals and things like that. Anyone know what is counterfactuals? What's a counterfactual? No? So counterfactual is where, when you are trying to, can you predict what is the outcome without actually doing it? That's what a counterfactual is. Can I generate a set of outcomes based on certain parameters, right? And then predict what can be the outcomes. So an example could be, let's say, in the real world can be where, let's say you have a patient who has a certain disease. Now you can have a simple thing would be a parameter can be we give this medication or we don't give the medication, right? What is that counterfactual is? What would be the outcome? Can we predict the outcome if we give a placebo or an actual medication? What could be the outcome, right? That's a counterfactual without actually giving the medication, because there is a risk, certain risk involved in doing that. So can we avoid the risk? Can we just say for this particular patient, if we give the medication versus not give the medication, what could be the outcomes? That's the counterfactual, right? And there are many such applications, right? And in ads, the counterfactual can be, because we have so many machine learning models and there are thousands of parameters we are trying to tune, because every model can work in at different thresholds. What we do is we have this massive sort of dual solver system where we can sort of try out different simulations for different sets of parameters, and then we can predict the outcomes, right? We can say, for example, I need to make 2% more revenue, right? Now I can run these simulations, right, which can take a few hours and use millions of parameters and simulate outcomes. And we can say, well, these are the outcomes for these combination of parameters, and this is what the prediction shows, right? So without actually using those parameters in production. So that's the counterfactual system. Okay, so let's start with query understanding, right? So for query understanding, we can use various techniques, right? One is sort of like, given a query and an ad, we can project it into a vector space, right? Because what we are trying to do is trying to see how close is the query in the ad, right? And the problem is that advertisers who are bidding on these queries or keywords, they don't know what the user is going to type, right? If I'm Amazon trying to sell running shoes, I don't know what the user is going to type, right? I might, if I just say, hey, anytime user types running shoes, then show my ad, that's going to be very limiting. You know why? Because people try searching in so many different ways. It's very hard to predict, right? I might say best shoes for marathons. Where is the running shoes there? But my intent is still trying to buy running shoes, right? Now that there's no way for an advertiser to predict how the user is going to type. This is where deep learning and AI can come into play, where I can actually project it into a vector space using various techniques like CDSM, FastText, Word2Vec, and say the best shoes or best shoes for marathon and running shoes, if I project it into a vector space, now I know that they're pretty close, right? The distance is not that much. And now I know that this could be relevant, or this could be an ad that's relevant for that query, right? So that's sort of one. The other one is NLP based rewriting and expansion. So the ordering of the words could be different, right? So if I say flights from Bangalore to Delhi, right? Or I could say the same intent, I could say flights to Delhi from Bangalore. The intent is the same, right? So if I'm Indigo, and what am I going to bid on, right? I'll just say, Delhi flights. But how do I know that the user typing in so many different ways, from to, all of those things? How can I decipher, or just say flights to Delhi in early in the morning? There could be so many different ways that the user might be typing in. So that's where we can use NLP techniques to say, regardless of the ordering of the words and the type of words being used, how can we decipher intent, right? And then word level tagging for deeper understanding. So this comes to play when I'm doing things like I'm looking for a certain product, right? iPhone 6 case, right? iPhone 6 case is not, I'm not looking for iPhone 6. I'm looking for a case for iPhone 6. So that's where the deeper understanding of what the user intent is, where I'm tagging each of those words to figure out what exactly is the product they're looking for. Because if I show you iPhone 6, when you search for iPhone 6 case, you're not going to select those ads, right? The other one is close variant generation, right? So when users type in, they can use acronyms, they can use plurals, stemming words. There's so many different combinations they can use. Also, they can make spelling mistakes, right? And or they combine words in weird ways, can we still figure out the intent? For example, right here, The Good, Bad, and Ugly, that's a movie, right? But when the user types in, they can just type good, bad, ugly, or they just combined good, bad, and then they had ugly. Now, if I use the NLP techniques, right, and use the sort of the vector projections kind of techniques, then I can figure out actually the intent is to say the movie is what they're looking for, right? So those are some simple examples where we can use deep learning to figure out the actual user intent. So the other one is next one is relevance, right? So once we have selected the ads, how does relevance work? So in this case, we're using query keyword relevance model. So we used to use fast rank model, which is a boosted trees model, right? And we were using a 300 dimension feature space. But then we switched to using deep learning more recently, DNN networks, where you're using a 300,000 dimensions, right? So much more richer. And you can see the ROC, how it's improved, right? It's improved like by 2.37%, which is very hard to get, right? Anyone know what is ROC? Good textbook definition. Across a range of values. Okay. And then, so you can also see how we reduce the defect rate. It used to be around 14.9% to 13.9%, so like a 5% reduction by using deep learning models. Okay, next one is user response prediction. This is a very complex problem, by the way. To predict a user click is not easy, right? And even though we show you the most relevant ad, we figure out your query intent, we figure out the right product to show, but to predict whether the user is going to click on the ad is going to be very, very difficult, right? So this is where we are using, again, we are using deep learning models, and this is called Woodblocks that we basically have built over the last 5 years. We've been investing in the system. And Woodblocks is where you have these term ID and ID DNN models, and you can see the number of parameters. So we started in around 2014, right? And you can see on the right side, you can see the number of parameters, how it's increased. So it used to be around 10 billion. Now it's like 50 billion parameters, right? So 5x increase that we have sort of increased it. And on the left y-axis, you see the improvement in ROC or AUC. So you got around 5% improvement in AUC, which is huge, right? To get 5% improvement is really, really, really hard. So evolving from a simple linear regression model or a logical regression model to a DNN model has given us a lot of gains. So that's what deep learning provides, is the kind of gains that you see here. So here's another example of how we can use deep learning, right? So in this case, an image is involved. So you can see that product there. It's basically baseball gloves, right? If you see what the advertiser provided there, it's called Louisville Slugger General or something. That's the name of the product. Doesn't say anything about baseball gloves, right? And so what we have is an image, and we have a title, and then we have a price, and we have the seller. That's what we've got. And from the query, we have baseball gloves. Now, how do we match this to that product? Because it's a very relevant product, right? But how do we but there's no information that the advertiser has provided that we can use directly to know that it's a relevant product for that query, right? So this is where we basically, again, project it to a vector space. So it's got multiple fields across text, image. We use basically we use CNNs, convolution neural networks, right? And we project this out to a space, vector space, and we do a cosine similarity. And so that tells us that this is a relevant product, right? So this is a combination of using those 4 things that I've listed there, right? The query, the offer title, image, and the seller name. All of that is projected to a vector space, and then we do a cosine similarity to get to know that this is a relevant product. So this is the one where visual product recognition, right? So if just given an image and nothing else, what are the attributes I can extract so that I can make it searchable, right? Because you can have a website which has some images, the description may or may not have all the rich information, right? Or a product page which has the product image. How do I know what are the attributes that are relevant for that particular image? So in this case, it's a category shoes, brand is Nike, style is sneaker or running shoes, color is black and white, gender is unisex. So if I can extract those attributes, now all of a sudden I have a rich attribute catalog to match the queries to, right? So here again, so we call it visual shopping. So let's say you have an image, right? So this could be a celebrity, right? Let's say you're looking at your favorite movie actors, some article, and there is an image that they're wearing some watch or some dress that you like. Now, if you can, so one of the things we are working on is something called shop the look, right? So now, can I go select a part of that image, whether it's a watch or shoes, and say, can you show me product similar to this, right? So then we can actually detect what is the product, right? So in this case, it's women's gray pants, women's blue jeans, or men's gray pants, right? We can also detect what kind of watch it is or what kind of shoe it is, right? And then we can show you similar products that are available in our catalog, right? So that's what we call shop the look, right? Or it can also be things like coffee filters. Any of the things that you see on the web, if you want to say, hey, this thing looks interesting, where can I buy it, right? Where can I buy such a product? So that's what we call shop the look. And so that is possible by using deep learning to extract the attributes from that image, the right attributes, and show similar images which have the same attributes, again using the cosine similarity after projecting them to a vector space, right? See how you can sort of solve real world problems using deep learning, right? Any questions? Yeah. Differential privacy. So privacy, I'll answer the privacy question. So privacy, I think, is a it's becoming more and more important because, as you know, we have to use lots of data to train the models. And, of course, everyone wants personalization, but people also want privacy, right? So how do you balance the two? So have you guys heard of GDPR? Yeah, so GDPR is this global data protection sort of policy that was started in Europe, but is being increasingly adopted across the world. The idea is that your data belongs to you, right? You as a user, you leave a digital trail of activity as you use the internet or various products, search engines, all of those things. Now, that product, the whole point of GDPR is that data doesn't belong to Microsoft, doesn't belong to Google, doesn't belong to Facebook, it belongs to you. So now, all these companies have to provide enough controls for you so that at any given point you can say, I want to delete that data, or I want to sort of do some whatever you want, right? So that's the control you get. So today, for example, every company like Microsoft, Google, there'll be a website or a dashboard. How many of you know there are these dashboards that exist? You can export, but you can also see all your activity, right? You go like my.google.com, you will see all the activity that you have, like including searches or what other data. You'll be amazed how much data that gets collected, right? Any activity that you've done. And then you can go and say, I want to delete those things. I don't want this data to be there, because that data is being used to show the right ads for you. Now, you could say that, hey, that's great because now Google or Microsoft can show me the right ad. But you can also say, you know what, I don't want Google or Microsoft to know that I went to this website, right? Or I did these activities, whatever it could be, right? Because that's privacy. So you can decide that you want to delete that data. When you delete the data, it's not just we are deleting data, actually. It's much deeper than that, because we are actually going in and deleting it from our training models. We are actually forgetting all that stuff. It's a lot of work we had to do, because we had all this data that was sitting there that our machine learning models are using. Once you say forget me, we have to forget you from everywhere, right? So I think you're talking about two different things. Deleting your data on the phone only deletes your data on the phone. I'm talking about data that's sitting in the, no, every product every search engine you use, every network, anything you do on the internet, that data is not stored on your phone. It's stored on the server in the cloud somewhere. So now all these companies, if you're a company like Microsoft or Google, then we are doing the right thing by providing you the controls so that you can go to Google, you can go to Microsoft, you can go to Facebook and say delete this data. But if you're using some other website, they may or may not provide you that controls. Correct. Snapchat does. But not directly. So basically, so what we do is it's anonymized to the point where we know, we would tell the advertiser, we don't tell directly, we allow advertisers to say I'm selling running shoes, and now based on your activity, if we can decipher that you're selling for running shoes, then we'll match you to that product. But we don't directly tell that you person whatever X is search for this, exactly this product. So there is a difference there. Yeah. So we break it down into sort of, it's n-grams, right? It can be broken into bigrams, n-grams, trigrams. So in this case, we are broken into trigrams, and we are encoding it. So we have the basic model can work for every user. Then as we learn more and more about from your activities, then we can make it more personalized. So it starts in a very generic way. We can still figure out based on your location and other things. There are some things we can do. So looks like this is a very popular topic. Okay, go ahead. Okay. Yes. Yeah, it's hard. It's a hard problem. It's like sending a child out into the real world. You send your child out to the real world, it'll learn all kinds of stuff. Send it to a good place, maybe it'll learn good things. Send it to some other like place, they might teach the child all kinds of bad things. That's like your machine learning model as a child, right? You put it out there, and there are people who can sort of deliberately train. This is what that happened. It's not like they just typed some random stuff. There were a set of people who had an agenda. They said, we're going to make sure they're computer experts, by the way. They're not like regular people. They know how machine learning models work. They know what kind of queries they should give to the chatbot so that the model can learn the bad things. That's what they did. They trained it. So it requires a level of sophistication. But yeah, we have to build those safeguards into the system, which we had not. We just trusted that people will do the right thing. And obviously, the real world, there are all kinds of people, so which cannot be trusted.
and then he enters searches to his preference. Then I go in and delete his preference. Can I retrain the model according to whatever I want from time to time?
So it depends on what you're trying to do. Are you trying to confuse the model, or are you trying to, right? So like I said, give the same example as chatbot. Yes, you can try to confuse the model by giving different types of data and training data and confuse the model. But for the most part, right, you folks are all computer engineers and scientists. You have all these questions, but majority of the population doesn't know, right? So they are going to use the services as they intend to use it, and the machine learning models will learn the right things and provide a better experience. That's the goal. Now, if you try to do some tricks like what you're talking about, yes, it can do some interesting things,
And
but
say if I don't delete the data, will it consider me as like a epileptic case individual?
no,
Or
it depends. No, so yeah, so basically we need to have statistically significant data, right? It cannot be just one or two queries and then we'll try to use that. It has to be statistically significant over a period of time for the model to really learn that it's a pattern, right? Okay. The other one is about like what we call attention models, right? So given a query, it can be a long query. How do you know what is important and what is not important? Because for long queries, it's very hard to match that long query to a specific product because it can have so many things. Now, how do we sort of figure out what are the things that we can drop and what are the things we should keep so that without losing the user intent, right? That's where again deep learning can come into play, where we can basically sort of shorten the tail, the tail, we call it the tail queries, right? By using these deep learning attention models, right? So these are like a couple of examples, right? So let's say you have a query called Surface Pro 3 keyboard, and then you have Microsoft Office for Mac. Let's say these are the queries. Now using attention models, I can tell, for example, if I drop keyboard, that's a bad one because keyboard is the product the user is looking for. And if you drop that, we'll end up showing you Surface Pro 3 computers or laptops, which is not what you're looking for. On the other hand, if I drop Microsoft, then it's okay because Office for Mac, there's only Microsoft Office for Mac, and it's okay to drop Microsoft in this case. So these are some examples of how we can use attention models to say, given a long query, which can have 4 or 5 plus terms in it, then which I can know, I can drop some terms to retrieve more queries. Here's another example. So in this case, the query is old Belgium silver coin bracelet person. I mean, that's a huge query, right? Now, how do I figure out what is the sort of the right things that I can extract from that query, which is important, right? And if you can see here, there are like 6 different ads, and here are the product. So for each of those ads, the product description is there, right? So for example, the first one has old Belgium silver coin bracelet person. Second one has Texas leather something, blah blah blah. So now I can provide a score for each of those terms, right? In terms of how much relevant it is for that query, right? So you can see coin and bracelet have the highest scores, right? So now I know that the user intent is a bracelet with coins in it, is what I can infer, right? Using this deep learning model. So now with that, I can figure out that's the right product to show. Because everything else around, like things like Texas or person, all of these are sort of things that I can sort of drop without losing the user intent, right? So that's the technique we can use to figure out what's the right product to show for such long tail queries. So here we are basically using sequence to sequence model for rephrasing a query, because a lot of times when you have these queries, like I talked about in the beginning of the talk, right? Flights from Delhi to Bangalore or flights to Delhi from Bangalore. There are different ways to phrase the same thing, right? So now can we use sequence to sequence model? Basically, it's an encoder decoder kind of an architecture, and then we use that to project it into an LSTM model, then use that to sort of figure out how I can rephrase those things, right? So here, for example, summer camps performing arts, I can rephrase it to YMCA performing arts school summer, right? Because I know I have ads or query results for this, but not necessarily this, right? Or Dodge Ram car seat covers can be Dodge seat replacement cover, right? So these are different ways of rephrasing the query while preserving the user intent, right? And so the next one is about using what we call GANs or generative adversarial networks, right? So where we can basically figure out what's the most relevant ad to show for a given query. So in this case, we're using sort of a min-max value function for we call query expansion CGAN is what we have come up with. And you can see that, so decile 7 to 10 is where we get the tail queries, right? And that's where it's a much harder problem to do long query sort of understanding, because it's easier to understand car insurance, easier to understand you know uh, you know uh, Google or Gmail. These are like very simple queries to understand. But if I have a long tail query to say 2007 Malbec red wine medium bodied, that's a long query, right? What is my intent, right? My intent is medium bodied red wine. That's my intent, but I'm going to give you such a long query. How will you figure that out, right? So this is where we are using adversarial networks, and you can see that the labeled quality results compared to sequence to sequence, the adversarial networks perform much better in all the deciles. And here are some examples, right? For example, the query is how to connect my tablet to TV. I can rewrite it to a much smaller query. So I can take a longer query and rewrite it to a smaller query like connect tablet TV, or how to hard reset my iPhone to reset iPhone factory settings, and so on, right? And here are more examples here. So with this, for example, before, if you search for how to connect my tablet to TV, we never used to show any ads because we did not understand that intent, right? Now that we rewrote it, connect tablet TV, we figured out, oh, I can show you a HDMI cable, and I have a lot more products to show, right? So now all of a sudden you have a much better ad retrieval model, right? So similarly, you can see all these examples where we were not showing ads before. Now we can show you relevant ads because we understood the intent by shortening or rephrasing the queries from that long query to a short query, right? And finally, when you use these deep learning models, they're very compute heavy because they have so many layers. And when you're running an massive online system, the SLAs are very, very tight, right? When you when you type in a query on a search engine, we have milliseconds to show the results. So our SLAs are very tight. So we have to do a lot of optimization. So when we started, for example, using deep learning, the serving side, the latency was around 52 milliseconds, which was not acceptable. So we did a whole bunch of work on the data parallel batching, memory contiguity, various things around LSTM optimization, vocabulary scoring, right? All of those things basically. So we brought down our latency from around 52 milliseconds to around 3 to 4 milliseconds, right? So now that's the kind of bar we have before we can put this in production, right? So it's not just about building these really complex models, but you also have to make it efficient so that that can be used in these online search systems. Okay, so in summary, cloud plus AI is really driving a lot of innovation, and there's huge opportunities to infuse AI in every product out there, right? And that's what Microsoft is doing. That's what a lot of companies are doing. And that's basically bringing a lot of rich experiences to the user. And Bing and Bing Ads is one of the largest AI applications. You don't see it as a user, but behind the scenes, like I talked about, lots of AI being used. And of course, we are using many deep learning technologies as well. So that concludes my talk. So I'll open it up for any questions you may have. Yeah. Yeah, so that's a good question. So Azure Machine Learning is primarily a platform that we provide for the developers out there, right? So that you can use machine learning libraries on Azure, bring your data to Azure, and use machine learning. Now for Bing and ads to, our scale is much, much higher, right? There are only few of such applications, right? You have Google and you have Bing, right? That's the level of scale that we have, that Azure right now can't support it, but we are working towards, but we do use Azure for various things, but not necessarily Azure machine learning itself. Yes.
I've heard that one of the biggest problems with deep learning is the explainability of the model.
Yes.
Like a black box. So is there anything being done in that?
Yeah, great question. So explainability of model, not just for deep learning, even for machine learning, is an area I think we need to do more on, right? Especially in areas where there's a lot of governance, things like medical areas where, if you're using a machine learning model to predict something, how do you explain it, right? So I don't think there are some early sort of work being done there, but we are in the beginnings of that. So I think there's a lot more to be done there. And I think there's an opportunity for someone to come in. I think that I've read about some startups in that area. Clearly, we need to do more there. Okay, thank you.